with this
He's the one who's
3.3.
starting off.
Alright, shut up. So we're continuing with this 3.3 thing. Okay, so we're not rotating past the vertices of the triangle, yeah?
Oh.
I guess we just think B1 is defined to be between B and A and C. Yeah? Okay. Alright. But we can have... I guess that's that one situation, but we can have like a totally different situation where we make like all A1, B1, and C1 collinear, yeah?
What?
So
How?
Well, you could if the
Oh,
triangle
okay.
is big. If you have an obtuse.
Obtuse. It's allowed obtuse.
Yeah.
Okay.
Alpha, beta, and gamma set.
Okay, buddy.
No, can you?
yeah, so I guess we're not rotating it to get that. So now we just have another situation. So
Where is my pen? There is my pen.
okay.
There is not my pen.
Yeah, so the way it was oblique
There's my
pedal triangle because we set up a situation where the pedal point was the point of intersection, right? And so that just happened to be 9 degrees. So then it generalizes it because then you get all the other points that make non-90 degree angles.
Yeah.
So okay, but they still all have circles that meet at that point too. Okay, so if you have 4 lines, okay, meet one another at 6 points A, B, C, A1, B1, C1.
D1. E1.
So that the sets of collinear points are A1, B, C. Maybe this is going to be... Let's try to draw that Simpson line diagram, yeah?
We're going back to Simpson line.
How do we draw that again? It was like...
Circle.
Draw a circle, yeah? And then there was a point P.
Drop perpendiculars.
Perpendiculars. Oh, so that one had to go up there. So
Yeah.
And
Why are you
one
shaking
is
so
good.
much?
I don't know.
Huh?
One that is
I want to just shake
one
your leg
down and
off
one
me.
up.
Yeah, one is one down.
Just roll one down and draw a straight line.
Yeah. Okay, slightly off. Alright, so which one's A1? So this is A, B, C, right?
Yeah, the A1's the bottom one. Right?
That's the B1. That's the A1.
A1 and that's the C1.
That's the C1, yeah?
And the P.
That's
the-
Simpson line.
Wow.
Okay, so... Okay, does this make sense? If we draw 4 lines and they meet it on another at 6 points. So I guess one of the lines would be like this line, right? That's one
Wait,
line.
is P a point selected?
Any point. It's Simpson's line, so yeah, you can figure that out.
That's 2 lines, right?
Yeah, and then that's 3 lines.
Three
Oh, wait, do we
lines.
disconnect all of the lines? Oh, wait. We
What
can just
are
count the
we
6
doing
points.
now? What?
Wait, we have 4 lines. 1, 2, 3.
So select any point.
I mean,
P
A,
and
B,
drop three.
A1, B1, C1's a line, right?
Simpson's line, right?
Simpson line's also a line.
Yeah, 4 lines. Yeah, that's the Simpsons line.
Yeah.
Okay.
Yeah.
So 4 lines
Is it
meet each other at
obvious?
6 points. This is any 4 lines, yeah?
Yeah.
Meet each other.
Okay.
6 points. You got A, B, C, yeah?
Oh, are we doing Miguel's theorem?
Isn't
Gauss theorem. What?
Miguel point.
Yeah, so A1, B1, C1.
Yeah, A1, B1, C1 is on the line, yep. A, B1, C is on the line.
Yep. So the sets of collinear points are A1, B, C, yeah?
Yeah,
This-
A1, B, C.
A1.
And
It's just any like 3 A, B, C
Yeah.
with at least with one of them being like with
Yeah.
one of them being
A, B, 1, C.
AC1, B.
Yep.
and
A1, B1, C1. Yep.
Yeah, and A1, B, C.
Is that the same by who
A1,
the Simpson
B,
law?
yep.
Yeah, that's because it's
So then the 4 circles A, B1, C1, yeah? So let's have 4 circles. A, B1, C1, yeah?
How does
That's
that?
my pen.
So
Why were you using it?
AB1,
Oh, because I thought it was mine.
Oh. Okay.
yeah.
Yeah.
A, B, C1.
ABC1. Okay.
A B C one.
That's a collinear. That's linear. Like
Yeah.
one
What the
line.
heck?
A,
BC1 is a line.
B. What's C1?
C1 at the top.
Very top.
Oh, what? I think A1, B, C1. Sorry.
A1, BC1. Okay.
A1, B, C1.
Alright.
A1, BC1, okay.
What is that?
Circle.
Circle.
And then you have. I'm guessing.
Is this
Double green pen.
is this the Miguel
You have
point?
Green
you
pen.
have ABC.
Okay, yeah, Miguel point. How do they prove it other than Spalsium?
Well,
Is that proof the Simpsons? No, it's not.
so you're saying Miguel's theorem is the one with Decalilia?
Miguel point.
Miguel point.
So it was this four circumcircles intersect.
Wait,
on
is
one
P
point.
on the circle?
And A, B, C.
And
Have a-
ABC, yeah.
Yeah,
Wait,
so
is P
so
on
it's
the
just
circle?
so if you just draw a random four line, right?
Yeah.
It's just like you just have.
Do they
this
have to
six-
intersect at 6 points?
Yeah, so they're saying the three circles.
four lines? Sure, yeah.
They could all intersect at 1 point.
Then in which case it would degenerate.
Yeah, okay,
They
so
could
we
be
have the
parallel.
blue, green, and black, yeah? Circles. So ABC is the green circle. C1, B. C1A, B1 is the blue circle, and BA1,
We
C1.
only have three circles.
What about
What about
A1 B1 C?
yeah?
A1.
A1, B1, C, or C also intersect that point. The circle.
B1, C. Okay, sure. We need another color.
Orange.
Don't have another color. Maybe we just make it red then. A1, B1, C, yeah. So what's the conclusion? The circles all intersect at P,
Yes.
right?
At P.
Okay, reanalyze it.
Well,
Oh, that could be
Or
another way to
cyclic.
think of it. Actually,
All cyclic.
yeah.
that could yeah.
So I mean, if it's 9 degrees, right?
Yeah, it seems fair.
These are-
Yeah.
Then they're cyclic with P because of the Simpson line.
Yeah.
Thing, yeah.
Yeah. And ABC is cyclic with P.
Wait, why is it on P?
Yeah, yeah.
though?
Definitely.
Yeah.
Huh?
What's the last one?
Huh?
What's the other one?
So you have
Wait.
AC on B1, A1 B1 C.
Oh, you have
ABC,
you have
what's the other one?
Red, blue, green, black.
you have A1, B1, C1.
So then
Oh,
I
yeah,
guess
'cause that's perpendicular.
I should make this point like a
Because C1 at A1.
Aren't they on a line?
B C1 A1. It's P C1 B.
they all intersect very close to 1 point.
What do you mean very close?
So like these 4 points.
Okay, but like
Yeah, you're like
you can't say that because if you draw any random four lines, you can also get that point, but you don't know if it's P or not.
Yeah, yeah.
Yeah, same for
It's like you're defining the P to, so you're using P to define the lines.
Cyclic, cyclic,
No.
cyclic.
So yeah, like so at the moment
Cyclical.
we don't know what angles P makes with those lines, right?
Yeah, it's obvious because they're all 90.
Didn't we define it to be all 90?
They're all 90.
Yeah, well they are if P lies on the circle, yeah.
Yeah. Oh, I was saying if P doesn't.
No, hold on. If P lies on the circle and they're 90, then
Then we're done.
we're done, yeah. But P could lie on the circle and they could.
Oh, are we
They
just
could
Wait,
not
did
be
we
90.
not
are we just
define
saying
them?
any collinear?
Isn't Simpsons?
Oh, okay. So they're not 90. Good.
There's just
okay.
4
Yeah.
lines, 6 points.
Yeah.
Okay. And it's important that they're collinear, yeah.
What's collision?
So
So we don't
how did
know.
they?
Same straight
How did
line.
they prove? How did they prove it? Other than Spalsium.
Can you not draw things on my arm? Like, she's drawing random stuff on my arms all the time.
Okay, so in this case, A1,
I can't
B,
rub it
C
off.
are 3
Don't
points.
look.
on lines. So A1, B, and C are 3 points on the lines B1, C1. Yeah. So A1 is on B1, C1. Yeah.
Yeah.
B is on B C1A. Yes. And C is on AB1, yeah? Okay. And the same theorem tells us the 3 circles have a common point.
Or the 4 circles. But sure.
Since the only common points for the last 2 circles are A1 and P,
Wait, what's up? Oh, are we seeing the red ones also as like that?
Yeah, it has to be. Because it's the Miguel point.
yeah.
How's my girl?
But like, the book didn't say.
Does the Miguel point require 9 degrees or not?
No.
That was my
It requires spiral sim. You just prove it. It's like a 2-line spiral sim proof.
What's the angle?
There's no angle chase.
P.
It's
a lot. No swastikas. No
A1.
What? Oh, can you trace back when did he start drawing swastikas?
Yesterday. It was what? Can I believe that it was only yesterday?
David, this is the reason I have to keep invading your personal space.
Can you believe it was only yesterday that he started drawing swastikas? It feels like it's been years.
This is why I have to invade your personal space, because he keeps trying to draw swastikas.
Then we can just expel him outside.
But we can't.
Or keep him into a little cage.
And that's like.
I keep having to cede space to him.
This is yeah.
What are we doing now?
So we're proving this theorem.
Yeah, you have to do spiral sim.
Yeah, like when you don't understand anything, I have no sympathy for you, yes?
To whom?
Anyone, basically. Because it's very fair. Like, the world is very fair. Like, it's kind of cause and effect all the way to the effect.
The 4 circles inside that P, that's what P is a pattern.
Is the world fair?
What are you given? It's just any 4 lines, right?
Yeah, so you have any 4 lines, right?
Yeah. Intersect at 6 points. 1, 2, 3, 4, 5, 6.
Yeah. So all the 3 circles have a common point of intersection.
All the 3 circles.
All the 4 circles have a.
How do you do that?
How are there 4
Is
circles?
it 3 circles or 4 circles?
4 circles. There's 1 just drawn, 1 already drawn, and 3 more. The red dot, the blue dot, the green dot.
How do you spiral sim this?
Spirals.
Yeah, apparently that's the way you do it.
Quicker side.
Wait, how?
So you take.
How many
Okay,
ways are there
so
to
you know
get
how
4 circles?
You assume that 2 circles line intersect, right? They have to.
Yeah.
And then so that's spiral. So okay, I'll just say AC1 B1 and BC1 A1. Sure.
A BC1 A1, okay.
Wait,
So like-
what's spiral sim?
And then so the P. So then the spiral sim takes A1 B1 to BA1.
A1, B1, B1. Wait.
Yeah.
Sure.
So therefore, it also takes AB to B1 A1 because spiral
Yeah,
sim comes in
that's
pairs,
What?
right?
Wait, something like that, I think.
And therefore, those 2 lines, therefore they, because of the spiral sim, converse spiral sim, now they line the circle as well. So therefore, all 4 triangles line the circle. I know it's kind of dodgy, but it works.
Well, because I forgot like the way you use spiral sim. Like,
Stop
you draw
Why?
the
No, I mean
Wait,
like he's
Edwin,
drawing my
yeah,
back.
with spiral sim you join the like points, right? And then we have a cycle called it.
How did they prove it? I'm curious.
So it's a consequence of what we just said. Okay.
So what's
How?
I haven't done spiral sim.
No,
Are we
not
doing
spiral
this
sim.
right now?
Don't use spiral sim.
But
There are other ways of doing it.
We're trying to prove that like there are 4 circles.
No, but he
There are 3
Everybody
circles
likes-
that intersect in the
everybody
same
likes
place,
one.
right?
He's gonna be like, oh,
Is it just any 3 circles?
no.
Miguel.
You have to prove that P is the pattern.
P is a pedal triangle.
You don't.
Could you shut up, please?
Well, I just said pattern. What are you talking about? You shut the fuck up. Anyways.
He said it again.
Can we actually just?
Anyways.
Can we actually just? I don't know how to try to
Wait, so
understand.
how would you prove it? How's the book prove it?
Yeah, so there's three triangles, yeah? Because the theorem before is it says 3 circles intersect at a point, right?
There's 3 triangles, yeah.
Sure.
Which three circles intersect at a point? So it's not the black circle.
Yeah, it's the red, blue, green circle.
Look,
Wait,
the
there's no
triangles are
3 points.
intersecting, bro.
There's no 3 points that intersect.
The triangles are intersecting. They're not like separate.
They intersect at B, yes, we know that.
So I mean, look, if worst comes to worst, it's meant to be a simple angle chase, right? Because the theorem itself is a simple angle chase.
But we need
Yes.
more lines than just that. That is not enough.
So I mean, if you really can't see it, can you prove that like the other colors that are not black
Would it just be just like
have a common point?
the case for pivot theorem, but with outside triangle?
Well, you've drawn it in. But can you?
So yeah, we're talking about the pivot theorem, yeah.
Yeah, but it's outside triangle. It should. You're saying it should work.
Wait, can a
Yeah.
pivot triangle work
Yeah.
outside the pivot theorem? Work outside the triangle?
Wait, like the point outside the triangle. Yeah,
That's what we're trying to do, yeah.
Yeah. Yeah, it is, right?
Yeah, this is exactly the same where it's outside the triangle, right?
Yeah.
So the only difference now,
So we should basically set it as the
yeah.
as
So
the Simpsons line first, and then see what happens when you move it.
Right,
Oh, okay. Yeah.
it's like this.
It's pivot theorem with like the thing of these 2 triangles, right? And then which pivot theorem are you using?
So look at
It's
this.
like this, but when it's outside, when this it's like.
So you have a triangle, yeah.
Yeah, it's like strength.
So you have a triangle, yeah. Like normally when you have that pivot thing or Miguel's thing, right?
Yeah.
You have like a
Please
circle
vacate the area.
that does
Thank
this,
you.
yeah.
Yeah.
Intersects the triangle
Thanks.
twice, yeah.
Yeah.
But now we're saying it doesn't intersect the triangle here anymore, right?
It's intersecting.
So we're just we have another like that.
Oh, yeah.
Yeah.
Okay.
And then we have another line going through that.
And then this point again, it's the same thing, right? But it does intersect both, yeah.
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 And then the last one also intersects.
And then, but now we have this one, right?
Yeah.
And instead of going like here,
Yeah.
because it intersects the line there now, right?
Yeah, so it's those 3 points.
Yeah.
Yeah.
So, so now you take this
Is that
point
A1?
and that point, right?
Yeah.
Wait, is that A1?
Huh?
The bottom point that you just.
The bottom point is B.
Oh, is that A1 and C?
Yeah, it is.
Okay.
I'm trying to prove cycling.
This is C1, yeah.
Okay.
Okay, yeah.
Dun, dun, dun,
This is
dun,
this
dun,
is
dun, dun.
A1, yeah.
Wait, that's C, isn't it?
A1.
Yeah, this is A1.
This is C and that's A.
Yeah.
Yeah. Yeah. No, I'm figuring this out with you, right? It's kind of more interesting.
Oh yeah, I guess you can angle chase, but
Well,
Like
Spam
Bell,
I
the
feel
Bell,
like the through line.
the Bell theorem is the Bell theorem is the angle chase. Like the
Bell
pivot theorem
theorem.
is an angle chase.
okay. So like,
Yeah,
Like,
I
if
can
two
tell how you
angles-
can just pretty easily
If
prove
2
it, but like,
circles intersect,
you just-
like A, B, and A.
so let the 2 intersections be like, wait, draw B1,
The third
B1.
intersection
Yeah.
has to intersect.
and then like the other intersection X, whatever. You just draw it. Yeah, it's pretty simple angle chase, but like, should be simple angle chase.
I guess the question is, does it follow from the previous proof?
previous proof of the pivot theorem.
Yeah.
Just think about like
It's just intersecting on the other side, yeah.
What on which point is intersecting? Which line on the other side? You mean the G point? Because like the pivot theorem is when you have where's my pen? Michael. No, the pivot theorem is when you have like a triangle, like two circles that intersect here and two circles that intersect it. Then you have 4 points, and they must intersect the third circle.
Like this. You have a circle here, right? Use this point to make a circle. Any
Yeah.
circle, yeah?
Any circle, it doesn't have.
Yeah.
And then it
And
has the
intersect
4
there.
points.
There.
And the 4 points.
3. Yeah, so this intersects.
And the 4.
Yeah.
Like just join in a few lines.
So we're trying to show.
Yeah, join C1, B1, and
It's really this point, isn't it?
Yeah.
We're trying to see this point.
so join
This
C1
point.
that point. Like let that point be X. Yeah, that's what I meant.
Wait, all three circles are supposed to intersect the same point.
Yeah.
So,
So we
Oh,
we
yeah,
can
yeah,
show
yeah,
that this one
yeah.
lies on this
That's
circle.
like simple angle chase, but like
Of course, yeah.
yeah, it's like 3 line angle chase.
But the question is if the angle chase is identical or if it's fundamentally different. Like if you need to use like the exterior angle.
Yeah, you need to
Yeah,
use the exterior angle.
exterior.
Yeah, so I have to use directed angle.
which one's the angle trace? Wait, how do you gonna angle trace it? Oh,
Just head angle.
Yeah, so like I guess you can join this up.
But I still like spiral sim.
Why does this look like more weird open?
Okay.
Just like
So where is actually the
Drawing on.
angles?
just let.
Yeah,
like,
so this is angle A, yeah? So this is angle A, yeah?
yeah, that's what I meant.
This is angle C.
So that's angle C there.
So
Yeah, in that tiny arc.
Oh yeah,
That's-
In that tiny B1X A1.
B1.
Where X is the other intersection. That's C. B1X A1.
like here, yeah?
B1X A1.
C.
Why?
Is that what you meant?
No. X is the other intersection of the circle. The two circles.
This is X.
No.
Yeah,
That
that's
the
what-
middle
X is
point,
here.
yeah. So it's C, and you're done. And you're done.
B1XA1, right?
Yeah.
What did you say?
Yeah, B1X A1, and you're done.
So the exterior angle. Yeah, exterior angle is B, right?
B1XA1 is equal to what?
C is equal to B1C A1
Wait,
Is it?
by bow tie theorem.
Ah.
What's bow tie?
Bow tie theorem is just the
It's just
simplest.
like
It's
same-
just the.
same-
Yeah, it's just simple. Everyone knows it.
Oh.
You use it every day and you just don't realize it. It's inside the quads and stuff.
Yeah, it's the bow tie.
What?
It looks
Oh,
like
yeah,
bow tie.
okay.
And, like, you can say that in like.
And then you're done.
Yeah, it's cool, 'cause
Oh, that is a cyclic chord. Yeah.
Oh yeah, indeed. So smart.
Can you actually just redraw the diagram? Because
You're starting on it.
I mean,
it's
it's
hard
like
to see everything.
That's still like a bit weird because
Oh
we
my
didn't
God,
use the
I see.
bow tie
Wait,
thing
colours
before.
are so bad.
Yeah, we
Hang on,
did.
hang on.
Did
we
we?
used it once and we used the exterior angle
Hang on.
once.
Did we?
Yeah, we used it just then.
So,
B1X A1 equals
Yeah,
B1C
this is
A1.
there, right?
In the previous
I assume
pivot
these
theorem
two-
proof.
Oh, we use
These
external
two-
angles.
these two-
Or
this
for
is-
yeah, it's because B's outside. That's why we have to use
Wait, what?
one bow
But
tie.
B1XA1.
You just have to, like, yeah.
Okay, so then.
Use that,
See,
and then that's
see
the
that,
base,
and that's
yeah.
equal to 180 minus.
Yeah,
this is-
it's,
Wait, B1XC1. B1XA1 is equal to B1CA1.
I was like doing this, right? So yeah, so you had this angle, right?
Yeah.
And that was doing like, and then you had this was that.
Oh.
So then that's 180, but like.
oh yeah.
Well,
That's so much.
that's the same.
Because last time we did a 360 minus
Yeah,
angle
it's
thing,
kind of
right?
like, now this assumes that.
Yeah.
they're all
It's
right,
like
they're
it's.
all right.
You just have to use the rectangle angles, which is really weird. Really annoying.
Oh well,
Yeah.
I guess you just assume this one and this one. So you assume this one and this one is here. Then this angle equals that.
Wow, I swear they use half the things I know in geometry ever.
It's just like
I just cold bash the questions. I just don't know how to do them.
It's related to your attitude towards geometry.
Yeah, I should fix my attitude towards
like
geometry.
geometry
I used to be
like
much more optimistic.
Yeah, I
Last
think
year.
in some ways you're a little too smart for your own good in some aspects, and obviously not like you're not a diet.
Why doesn't callback all the time work all the time?
I don't know why it's so good. I've only started I've realized how good callbash is in the last month.
What about just
My attitude towards callbash was pretty bad towards at the start of camp, but now
Alright, so
very good.
a big poke?
Oh, it was really easy.
You deserve a big poke.
yeah, so I guess I still need to be a little bit convinced that this is a consequence of the other theorem.
What
'Cause
is
it
it?
does look like we're proving it a little bit differently.
Is a
but
consequence of the pivot theorem?
Yeah,
I mean, it's the same as it's part of the statement of that theorem. So maybe when we proved it, we should have included this case. But that's a different thing than saying we actually proved this case without arguing before. Yeah.
Wait, is that a consequence of the pivot theorem?
Well, it is the pivot theorem. Yeah.
What? So
what?
Okay. We're not done yet, right?
Yo, what are we trying to prove? Like that we're
Well,
not done.
Oh, guys, we're not actually done yet, right?
Are we not?
No, we're not done. We only have 3 circles, yeah.
Yeah, but by similarly, the other one also works.
What other one?
So the
The
other
one
one's
A, B, C,
the what other one's
ABC,
the
right?
A B C, right?
G. Yeah, A, B, C, X.
Yeah. So you just redraw the diagram to 2 small circles and the A B C.
It's a
Right.
symmetrical.
And it will-
it's symmetrical.
Yeah, it's symmetrical.
A, B, C, X, and G, B,
Oh, wow.
A1,
So you
X.
can't just prove Miguel proof
Yeah.
English.
And we also.
Oh well, I still like spiral syndrome.
So Miguel's theorem.
This one. No, that one. Yeah, we proved this one.
Wow.
But like.
You're so mature now.
That's the
So
one.
what over the week I'm just gonna Michael.
Yeah.
Over the week I'm just gonna reread the geometry revisited, like the ones you've
Yeah.
covered, because like
Uncolored,
Yeah.
Because
and
it's
it's
good.
pretty much clear what we need, yeah. Because I've only skipped to the stuff
This
that,
equals that, you're done.
yeah.
like when we had more time, we kind of covered it very like slowly and in depth.
Okay.
But now we're
Given
skipping
two
to
of them,
sort
you
of
can get the other one. You draw this in, and then you
more
can draw
practical
this
aspects.
in. Yeah.
Well, then we
this
Wait, why is this
Right.
bad?
Don't draw that. You really draw that.
What? I want to know that.
I see how to pivot theorem, but
I want to know that.
You know, I answered these questions before, and I talked to you like repeatedly over and over again.
Why?
no, I mean I see the pivot theorem,
Well, what are we doing now?
but this version.
No, okay, so
I still
explain.
like spiral syndrome.
So explain why
Yeah, we're fine.
Why?
P,
Similarly.
P.
We can either consider like this triangle or
Is it
consider this
P C1?
like these.
Wait, which circle do we need to add in there?
Similar. Like yeah.
We need
this
to
and this are
add
similar.
the
Like,
ABC.
similar, because we
ABC.
Yeah.
Like
Like, You don't think about it with the big circle. You just think about it as like. So there's four possible triangles. Like, sorry, there should be 5 possible triangles in the 6 points, but then you disclude the largest one that's not connected, the BC one C.
Oh, yeah.
It's like you just join every other triangle other than B, C,
Yeah.
and C.
So you have this angle equals this angle, right? And you have this angle equals this angle, which equals this angle.
Wait, so did you already get it?
Get what?
That ABC also passes through the point?
Sure, you can angle chase it as well.
Yeah, I got it.
No, I don't think it requires an angle chase. Hold on. Well,
Or similarly.
Yeah.
It's not that hard.
By symmetry.
by symmetry.
More like case if you think about it, A1 BC1 and BAC are like
A1, B, C1, yeah? Yeah, the red circle, yeah?
the red circle and the
The undrawn circle.
which one's the red circle? No,
GBC.
the
Are
black.
you talking about the lower green circle?
If you look at this first top
The
diagram.
top diagram.
Green circle and black circle are they're like similar. They're like similar. Well, like they're the same idea.
Reflection.
Yeah, they're like They're the same idea. So if you draw on that side and you draw on that side, it's the same thing.
Oh, okay. So you're saying green circle.
Like,
So green circle is the one that we're trying to add, right?
yeah.
Yeah.
So if you considered
So how do we?
if you consider like A, B, C, and then drawing in A1, B1, C1, it's the
Oh,
same
I
as
see.
considering A1, B, C1, and drawing in A, B1, C.
Oh, I see. So you're basically using the black circle as the original circle, as
Yeah.
the original triangle.
Yeah, you can. And if you do that, then it's also very easy.
Okay.
If you want to use the black circle, is the original
Wait, how do we know the? So
a black triangle is the original triangle.
so wait,
You
how
have
do
P
we
is
know
on
the
the
red circle?
you have P
on the
you have P is on the black circle, right?
Angle chase. So you get the alpha alpha.
So you have what?
CC,
Yeah,
right?
so you have P.
Yeah. So
the
what is
assumption
angle
that P
B?
is on the black circle,
angle.
and you're trying to
B,
prove it's on the green circle.
180 minus A minus
Yeah.
C.
Yeah.
Yeah,
You're
and
done.
then you construct.
Because-
Oh, okay,
construct
Some
AP.
people, yeah, yeah.
I didn't see because.
Yes, I see. So
Oh, yeah,
if you basically
But X is
pretend
the-
you
you're
did the
proving
same
that X
thing
is the
without the
same
black
point as
circle,
the-
Yeah.
and
as
that's
the
that
middle
point,
as
right?
the-
Yeah.
It's collinear.
so- and then
to
it
G.
has-
You get angle chase as well because
No, not
you can do
really.
a quick
We just
angle chase
we
and
just
you still
assume
get it.
you know that the two circles intersect,
You
right?
have
And you
to-
assume that
you
the
can get,
intersection point also lies on the
Angle
first.
APC is equal to angle A1PC.
Oh, we're moving point X to the circle. Sorry.
Yeah, you can prove that point. It's just-
Uh-huh.
And then that just tells you the cycle.
Bum, 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 bum,
Hmm.
bum, bum. Why am I singing that song?
What does it mean?
Okay, like it is quite funny. You get really tricky because these things that hit.
What?
But then like as way of like you get
Wait, what
you
happens
get
if
triggered because
you're-
it hits you every time.
if you're a spy player? What does that mean?
Wait, did
Or
you get it
go
in the
to
same
cycle.
way? Did you see it another way?
Yeah.
So, okay. So instead of using, yeah, you still use the two small circles, right?
Mhm.
So instead now,
It was
angle AXC, yeah.
Were we talking about the top one or the bottom one?
Oh yeah, bottom diagram.
Yeah.
So instead now angle AXB1, whatever that is. Yeah, that's B1 equals AC1B1.
Yes.
Right? And then angle B1XC equals angle B1A1B. And you're done. Sorry, C1A1B.
Oh yeah.
Or B1A1B. That's the same thing.
Yeah. Yeah. I guess I would prefer you don't see it with an angle chase, if that makes sense.
Oh, sure.
Because you're missing the relationship. So you know how we were saying counting is like, you know, you can count everything by bijecting to 1, 2, 3, 4, or you can like say that they have the same number of things in them, right? Relating things to each other. Like I would prefer you relate it. Yeah, because angle chasing is going reproving everything, right?
Yeah.
But how else would you see that the other circle, the A, B?
So this is what Habib was saying, right?
Wait, what was Javi saying?
Yeah. So this is so like. So at the moment, right, we kind of just ignore the black.
The
We
red.
ignored the green circle, yes.
Yeah.
Right.
Yeah.
But we could put the green circle in and ignore the black circle, right?
Yeah.
Sure.
And you have the same thing.
And
Yeah.
we have the same thing. And because there's 3 circles at that point, when you switch it, it'll have to be that same point of
Yeah,
intersection.
that's what I meant by symmetry.
Yeah, well, that's good.
We have to be a bit more clear when we say bisymmetry.
But like that's what I said as well.
It's basically the same idea.
Yeah.
Spiral sim is like you get. It's like similar switch on circles. Do you know what I mean?
I don't
Similar
know.
switch is okay. So you have 2 similar triangles. Let's say ABC and ADE.
Oh.
Then ABD AC is also similar.
I'll show you.
So basically, I get it.
It's basically like if you rotate about P to get the
So
green.
basically, you have ABC and AD.
Oh yeah. Preferably not joined together. Sorry. Like this.
In the same orientation.
Oh, okay.
Yeah, the same one. Then
Sure.
Well, so
this
They're A, B, C, and A, D, E. So A comma.
B, C.
D, E, yeah, it's same orientation. Then A, B, D, A, C, E are also
Oh, okay.
similar. Yeah. It seems very logical. You can also prove with angle chase.
Yeah, it's just simple because these angles are the same.
Yeah.
So these angles are the same as well. And because like these sides are the wait, they're similar. They don't have to be congruent.
No.
So they can be not congruent.
Oh yeah. If they are congruent, then the other pair is congruent.
Oh yeah, but if it's just they're just similar.
Yeah. Then the other pair is similar, like that pair and that pair.
A B A B.
Yeah,
and
that.
C, and
Yeah.
this.
And yeah, that yeah. And you see how this is connected inwards now, and you can do the other way around.
Those switch.
And then you know that this angle is equivalent to this angle, right? So
Why is there staples on the tape ground?
you can do some weird stuff with similar stuff like similar spiral sims.
Similar.
Yeah, and of course, yeah, like you can also see it with angle chasing as well. Yeah, that's fine. So yeah, you did get it.
You draw some lines and you get
Bum, 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 bum. But why so fast twitching? Why moving so fast? Like you just jerked into the corner. Jerked back.
because the corner is last.
Yeah, but that's how people in the medieval time do. They die in like their sleeves, so yeah, they just die in cornices. Like their piles. Their bodies pile up.
It's always fun.
There's like 20 people in a room.
Oh, and they just smother each other.
No, they just die early, like 20s, 30s.
Why do they die very early?
Bad sanitation, malnourishment.
Okay, so now in this special case, when the first three circles,
They die.
in the special case when the first three circles have AP, BP, CP for diameters.
Wait, A, B, C, B, what? A,
So,
P, C,
when-
P.
AP, BP, and CP for diameters,
Yeah.
right?
No, BP or B1P.
So that's basically just saying now it's like the Simpsons thing, right? Because now it's perpendicular, yeah?
Yeah, okay.
Okay.
Then nothing else.
Simpson.
Then A1, B1 is the Simpson line of P for triangle ABC, yeah?
Wait, CP is the diameter
Yeah.
of what?
What?
Oh, okay.
Of the circle. Yeah, so keeping ABC and P fixed, we can rigidly rotate the three lines PA1, PB1, and PC1 about P, yeah?
Oh.
Through any angle, so as to obtain an oblique Simpson line. Does that make sense?
Oh, so like you know how we could pivot.
Oh, so all the angles are the same, but not right angle, right?
That's what
Oh,
So all the angles are still the same. Are all the
Oh,
angles
right.
still the same
Okay, cool.
when you rotate into an oblique Simpson line?
Yeah,
Does
it's
it still stay like?
How?
I'm not sure.
well, it doesn't stay at 9 degrees anymore, right?
Yeah, it
it
doesn't.
doesn't-
But how
does
does
it
that
still
also-
stick?
It
Yeah,
has
yeah.
to,
9
right?
degrees.
It has to.
It's defined as staying collinear.
Yeah, he's right. Yeah, it's kind of it's defined as staying collinear.
Because
But
you
what
have to have a
happens
line.
though-
It's defined as rotating about P, maintaining the linear.
Because the point is
Die early.
Same.
Huh?
Nothing.
What?
I probably already ingested a fair share of ink.
Yeah. So obviously, if the point stays on the circumcircle, right? Like the Simpson line is basically fixed relative to that, right? So these are all different. They're non-Simpson lines for that P.
Yeah.
But yeah, like the property is that they're collinear and they have all the circles passing through the point. Yeah. So this. Yeah. So the Simpson line was when it was 9 degrees. Now you have all these other angles that are collinear.
Napoleon's here. Oh, we're finally getting onto Napoleon's here.
Finally, does that mean this is? Just
Oh yeah, that's the theorem. That's the theorem I was talking about.
So this line contains new feet A1, B1, C1, such that the three lines PA1, PB1, and PC1 make equal angles. PA1, PB1, and PC1
Oh, that's what
Okay.
I was talking about. The angles can the angles stay
make
stay
equal angles in the same sense of rotation with the three lines B, C, CA, and AB.
Oh, you say that the angle is the same. Okay, that seems true.
Okay.
That seems true.
Yeah,
seems
yeah,
legit.
sure.
Seems legit. I wonder who said that.
You haven't been annoying for the last time. I said something too soon.
That
Who?
wasn't me.
Yeah, that was.
I did not throw the pen at your back.
I was, gonna
Was
say,
that you?
He wasn't being annoying for the last half hour, which is very
Because
good.
I was sleeping.
But then
Okay, so
he,
theorems.
he poked him again.
So I'm gonna pass it forward.
Because you used
Okay, so then
the catchphrase.
basically state two more theorems, and they're pretty related to each other. And then that's it. That's it for this.
Napoleon.
Well, not the whole section, but.
Why are you still chewing the cream?
I don't know. It's a habit. Bad habit.
I think.
Okay, I'm gonna keep this diagram up just in case it's helpful anyway. So if similar triangles
Is this a
PCB,
Is this a bin?
yes, if similar triangles PCB, CQA,
PCB. Where's C again? PCB. CQ.
What's Q?
PCB, CQA.
Small diagram.
CQA.
Oh, I think we're back to this other diagram.
That you just rubbed out.
Are we doing? Oh yes. Are we doing?
Alright, if you have this other diagram,
Are we doing Napoleon's theorem? Yes, Napoleon.
Finally?
have you heard of it before?
No.
Isn't it like?
But Napoleon.
Isn't it
is not a long
collinear?
version.
I
They-
swear it's collinear. Like the things are concurrent.
So
Oh,
it's A, B, C,
Let me
right?
be right for once.
P, Q, R. Yeah.
Are they equilateral? I assume so.
Why?
Why?
I assume the specialist.
Yeah. If they are equilateral, then
Will make a lot of sense.
BQ, CR, and AP are.
Okay, so if similar triangles PCB,
Oh,
CQA, right?
yeah.
So that's the bottom diagram, yeah?
They're only similar.
And BAR, yeah? So these outer three triangles, yeah?
They're all similar.
Are similar in such a way, you know, they add up to 180 or whatever.
But do
It
they
does-
have
it
to be
doesn't
in the
actually-
correct orientation? Like similar with all three sides, all three corresponding sides
Yeah,
touching,
yeah,
the,
yeah, yeah.
touching the inside, or can they be arranged in weird ways?
No, it's
they're
arranged in a
not.
weird way.
They're exactly not doing that. Are erected externally on the sides of any triangle ABC. Yeah. Their circumstances form a triangle similar to the three triangles.
Wait.
What?
Okay, wrong theorem again.
Oh. Wait, how do you know Napoleon?
So the circumcenters,
Wrong theorem.
so wherever they are, right?
Are similar to the three triangles, respectively.
Yeah, that's kind of interesting.
You can angle bash again.
Like circumstances. Can't you just
Yeah.
draw like a perpendicular bicycle of AC, AB, and BC?
Yeah, that's what you mean by angle bash.
That's not too terribly hard, is it?
It's like I just found it's like whenever you learn a bit like a higher technique, you just call all the the lower order techniques bashing.
Angle bash is good.
I mean, once learned coordinate geometry, and I thought that was so good. That was the
This is
proper
so good.
technique.
Hey,
But then
Zing,
once
Right,
you
you
learn,
gotta focus on
This
this
is the
because
point
this is like new
Bash is
stuff
the-
you need to learn, yeah?
okay.
do you know addition bashing?
Don't indulge.
I learned.
1 + 1.
Alright, so this is
Okay,
so the centers are called O1, O2, O3, yeah? With O3 being an R, so it's P with
Wait.
O1.
Can you write down which
Shut up.
triangles are similar so we don't get confused?
The outside triangles are similar.
Yeah, like in which orientation?
Mm.
Just to like not make everybody confused, including me. Actually, I already have it. Doesn't matter. You can still write it.
Hey, buddy.
Your dry humor is not appreciated.
And then tell me my link is not out. It's a good pen.
So
Sikomsenta. Dun, 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 dun. Are you sure it's PCB, CQA, and BAR?
Yes, it is.
CQA.
Why?
Is it?
The way they're
Yeah.
similar.
Is it? No. Which order is it again?
Which order is
Yeah.
what?
Which order is the similar triangles in? Like, can you just write it down?
The way they said it.
Yeah. You have to do it the way they said, otherwise you won't work. Are you sure it's PCB, CQA, and BAR? Because that doesn't.
PCB, CQA, BAR.
Wait.
PCB, CQA.
PCB.
Yeah.
Yeah.
Ah. Yeah, that makes a PCB. Wait, PCB?
Yeah, just the three outer triangles. The circumcenter of the
Wait, so
the
PCB,
circumcenters of the three outer triangles form another triangle. that's similar
CQA, and
to
what
Each of
else?
the three triangles.
Wait, what are the similar triangles?
All four.
6 and BAR.
1, 2, 3, 4.
BAR. So BCP, CQA, and BAR? That
Well,
doesn't
that's not
seem
even
right.
symmetrical.
That's not even symmetrical.
Yeah,
Then.
it's not symmetrical because I think
Because
I
you
think
have.
they only so they only emphasize.
AQC is symmetrical.
What is going on?
Star of David.
Huh?
The Star of
AQC
David.
is
Could you
symmetrical,
shut up about your Nazi thing?
Because
What?
Try poking.
like if you have it AQC, right? The AQC.
No, he
Oh,
wants-
maybe it's RAB. Actually,
Is that
RAB.
not the same? Well,
Ankle
Yeah,
bash,
these are
ankle
different,
bash, ankle
So,
bash.
it's like this,
Dun, dun, dun,
and then the Q should go to the A. The Q goes to A, and then A should go to R. And then C goes to.
Bash.
Oh wait, no, it's fine. It's fine. Wait.
Bash.
Okay,
Oh,
that's
C
fine.
goes to B. Yeah.
Okay.
Wait.
I'm gonna like.
Stop.
Okay.
The only
That's
similar-
actually
the only thing we don't have
Scary?
similar, Really?
No, that is actually a dog.
Right.
That is very Pokemon.
Okay, yeah, no, it's fine.
Are you sure? Oh, so
Yeah.
what order is it in? Verify.
CQA,
CQA, yeah?
BAR.
No,
Yes.
it's RAB.
No.
Yeah, it's RAB.
No, C. It's BAR.
I swear it's RAB
That's
now.
what you
Because
wrote down.
What?
You wrote it down.
CQA. Is it not ARB?
yeah, he wrote it like that, but I don't think that's the right orientation.
Look, right? So.
Whoa.
Alright, so you have.
RD.
Right.
Like
Okay,
ACBA here.
Watch this, right? So, yeah, bottom one.
Yep.
Goes to the bottom one.
Yeah.
Goes to the bottom one, right?
What do you mean bottom one?
So CBP.
Yeah.
Bottom one. Bottom of this triangle. Bottom of this triangle. Bottom of this triangle, right?
So are you thinking
Q.
bottom as in this?
QAC. To right one. Right one. QAC.
What do you mean right one?
So you're matching
Why
them
does
up.
the order matter?
You gotta do this and this, right?
Wait, so
Wait, why
B-
does the order matter?
so you did BA, so
I
you
mean,
did
why does the order
PCB,
matter?
right?
So
you did
want them to be similar
Right,
in this
left,
orientation.
bottom.
Yeah, right, left, bottom, right? So Q. What? Yeah, this is CQA is bottom, right, left. Bottom, right, left. Bottom, right, left.
So yeah, it's
No.
BPC.
You don't realize that this is the bottom now.
Why is that the bottom?
This is the bottom. This is the bottom. That's the bottom.
What do you mean?
Wait,
That's what.
bottom is the. So
No.
you just say anti-clockwise order, okay?
I
Say
don't know.
anti-clockwise. BAR,
Can't
that's
you just-
anti-clockwise.
Alpha. Beta.
Wait, can't you just say
Are you
BPC,
sure it's
CBA,
like that? Yeah.
ARC? Can't that's way better. Just around the big. Just BPC, CQA.
Oh.
ARB.
Are you sure it's
Isn't
like
A
that?
lot better.
CQA, right? Alpha, beta, gamma.
Yeah.
BAR. Alpha, beta, gamma.
No, it should just be ARB then.
Wait, why? Then you start with beta. Cause
Yeah. You start with CQA, BAR. Oh, is that how the triangles are ordered?
Yeah.
Then that's
Wait,
right.
why?
how did you think they were?
Oh, I think they're ordered like this, then that, then that.
Wait,
Oh,
why?
you turn them.
Yeah.
Right. Oh, right. Yeah.
Oh, they're not rotated.
No, because if you turn them, this angle goes to there.
Oh no, I meant rotated, not like that. Like rotated, like
But
kind
that's
of
the
very
same thing.
weirdly.
That's the same thing.
Oh, wait, I see what you mean. Oh, so you thought the gamma was there?
Yeah, and the veil was there.
Oh, right, okay, yeah, fair enough. No, then your thing's still wrong, I think.
No, it's right, but
It doesn't matter.
Why
Are you
does it
sure?
matter?
Yeah,
So-
no. Because if you
I don't care
doesn't-
now.
yeah,
I don't
yeah.
care now. Okay, I'll just go along with yours because your one's guaranteed to be kind of
Alright,
right.
We have solved the issue.
Okay, so I guess we'll figure out what the orientation should be because I think
Oh,
it'll
we're
work
figuring it
somehow.
out
We'll
again.
figure it out, yeah.
so. It's like if you take the three intersections at here, right?
Yes.
This is like the radical axis,
Yeah.
Otherwise also the radical axis.
and so the centers of these two circles, right,
Are perpendicular?
are perpendicular, right?
Yes.
Huh?
Yeah,
The radical axis.
yes. It's Jesus Christ. Who doesn't recognize this?
Oh my gosh, you're so politically annoying.
Incorrect. Politically mentally challenged.
Sure.
Politically incorrect.
Politically incorrect.
So all of them have like
Yeah, all of them perpendiculars. Yes. Yes. To the radical axis.
O1, O2, O3, yeah.
Perpendicular.
These are all perpendicular to here, yeah.
Yeah.
So oh. Oh, okay. So
What's
I guess
the big O around?
so the middle point, right?
Yeah.
Has angle 180 minus p, yeah.
Huh?
Yeah.
Oh,
Oh, okay. Okay.
how?
Yeah, because it's a cyclic quad, yeah.
Oh, okay.
Well, it's the
That
pivot of both. It's also the pivot of O1
Oh, yeah.
Is that enough?
So yeah, because this is cyclic quad as well, right?
And that's P.
Oh, you can
yeah,
have it
yeah,
twice.
yeah. Big brain.
I think it's better to start with drawing the three
Brain of
kites.
bigness.
You get it now?
Oh yeah, I think it's like the diagram makes more sense if I start drawing with the three
Actually-
kites.
Can you
You guys are lucky that you're smart. It's like it's very. It's
can
like,
you assume that?
It saves you a lot of trouble. Like you don't have to have. You don't have to do the stuff the right way. And
Can you assume that?
Can
what?
you even assume that we're?
I don't think you can assume those 1990. Like you can only
No.
assume one of the 90s.
You know
What?
the
No.
90 because...
Because you know the radical axis is perpendicular to the center
We
line.
proved
Yeah,
that in
yeah,
algebra
understood.
weeks ago.
Huh?
Yeah, understood.
Yeah, so they're all 90, right?
Yeah, but they don't necessarily intersect at that one point.
Yeah, they do. Radical axis intersects at one point.
Wait, so what are we proving that? Oh,
We're
proving a
that they're
different
similar.
question. Sorry.
Yeah.
Yeah, so we know from previously that they intersect at one point, right?
Yeah, no. Sorry.
You could have knocked this top over. He did not. He did it
By the pivot theorem.
Sure, by the pivot theorem.
Yeah. Well, not quite. Like it's the one before that. Remember with the simple line? We didn't have them lined up. Like when your question was like, did they ever make a straight line? Yeah, like we were at that point before they made a straight line.
Oh, that was like so long ago. Already.
I already forgot.
Wait, what did he forget?
It's like a meta forget.
What? Wait, what did he? No, I don't concentrate when I'm drawing stuff down on my paper. Like, what did he say? What did he forget?
What did Edwin forget about scene forgetting?
What did you forget?
This is not helping, is it?
Yeah, you better get in there, David, before typing does, and then you'll be the last one.
Funny,
I
funny.
love typing's nice.
Oh, don't be a Jew.
Shut up,
When
David.
I upload this, it goes, is this appropriate for children? And I'm like, I guess so.
No, it's not.
Made by children.
I guess so. Because the offenders are all children.
Yeah.
Like, it's
What
the
do-
children.
What do you mean are all children?
Surely
That
all the
implies
acts
it's
of
like-
Surely the acts of children.
Why does David
are
David
appropriate
Clark
for
keep his
children.
mouth shut for some reason?
Not always.
He has no self-regulation. And I don't think he realizes it's a problem.
Ah, yes. So come on.
We say this stuff in school all the time, so I say it.
Yeah, actually,
I know, but I don't think your schoolmates like it.
Well, our schoolmates say it all the time.
Doesn't mean they like it.
The soul ring.
It's like people can't help it.
Bolko kids.
Yeah, exactly.
Soul ring.
Alright, okay.
I want to buy some
Bulk
soul.
of.
So that's pretty cool, yeah. So that means they're all
Yeah,
similar.
funny.
They're all similar.
You love how I feel like Jeffrey's not in your
Okay.
favorite Jeffrey's.
In particular, if equilateral triangles are erected externally on the sides of any triangle, yeah, then their centers form an equilateral triangle.
Well,
Wait,
equilateral
what are we
triangles
doing?
similar.
Where?
Wait, if they're in
Now there's an
equilateral.
equilateral triangle.
Wait,
Wow.
is
You
it?
missed it.
Is it if those three triangles are equilateral?
So
Yeah.
yeah, if
Yeah.
the similar
All
if,
equilateral triangles
yeah,
are
if-
similar.
yeah, all equilateral, yeah, good. All equilateral triangles are similar. So if these are equilateral triangles, right?
Yeah.
So no matter how they're orientated, because
Okay, that wasn't my
Because
theorem.
equilateral triangles
There's a
can't really
theorem
be
which states that
orientated.
three lines are concurrent with like some random crap.
Wait, if they're all equilateral triangles,
this theorem has piqued much
No,
interest
they're all
in
equilateral
in the group. Long have we awaited in our search for that theorem about the random crap. Okay, so
When the teacher said something.
Because he said it.
so is it?
Very cautious.
Okay, so yeah, so apparently this is called. Wait, so okay, so at any rate, it is convenient to name the triangle O1, O2, O3. So this is after all that Napoleon spiel, yeah.
Spiel.
So, in the case of the equilateral, to name the centers the outer Napoleon triangle.
What?
Of course, something has to be named after him.
because
Okay.
he's a famous French general.
Of ABC. By analogy, if equilateral triangles are erected internally on the sides of ABC, as in the figure 3.3c, yeah, I mean, so you just, if you make the triangles have,
Who said
If
your
you-
hair's spelled nice? I'm eavesdropping again.
This video is banned in
You need
Germany.
to break your habit of eating.
I wonder why. He's
He's
want to find
Yeah.
one. He's want to
so
find
guys,
some way to.
it's almost done. So if basically, instead of putting P on that side of BC, you put it on the other side of BC, right? So if you put P, Q, and R on the other sides of the triangle, it doesn't mean it's inside the triangle, yeah? It just means that they're on the other side, yeah? You can still form the circumcenters, right? And so then you can get, like, you know, sometimes you can get these O's, they're called N's, to be
Wait, how
inside
is
the
that
triangle.
cyclic though?
Inside the triangle.
The
because
kite is
you try-
cyclic,
oh,
but what,
because
how is the
triangle's
like the
on
little
like-
quadrilateral cyclic?
Huh?
How's
Wait,
the
is it?
small
It's inside the
quadrilateral?
triangle.
Because 90 and 90.
Yeah.
Oh yeah, that the other pair of lines.
Wait, it's inside the triangle because like if it has angles of two, right?
Yeah, I guess. So are you justifying why when the circumcenters are inside the triangle?
Yeah, like that would be what. They can't all be inside. Only one of them can be inside.
Oh,
Yeah, so I guess this really leads on to the next section, which we're not going into.
which is
But
what is
so
the next
this
section?
statement says the outer Napoleon triangle is equilateral. Yeah? Okay.
Outer Napoleon
Napoleon,
triangle.
like the one that's made by three points.
Wait,
Yeah, so
so is
whenever you
this
have-
thing the Napoleon triangle?
Napoleon triangle.
So this outer Napoleon triangle is the one when you have three
Three
external equilateral triangles.
Okay.
And the outer Napoleon one is the O1, O2, O3, yeah?
Okay.
The inner one is when you have the PQR on the other sides of
Oh,
the
and PQ on
sides.
the inside way.
Yeah.
But
and
won't
it's
they be
called inner
over,
Napoleon
won't they be
triangle, yeah?
overlapping each other and like in all sorts of weird ways?
Okay,
yeah,
This is such a stupid-
Yeah. So apparently this other guy like
Wow,
proved
Napoleon was such a
that
genius.
both the
when he
outer
proved it.
Napoleon
Yeah,
triangle
Genius more like
and the inner Napoleon triangle are equilateral.
What?
Okay, but that's for another day, I think.
What? How?
You're just like a reaction box sometimes. It's like, how?
Like
When?
a calling station.
Yeah, like a calling
Who?
station.
Why?
He's like, you ask like a question and it's like, how? What was that? P. And I'm like, oh, I'm trying to concentrate on one line of thought here. He's wrecking my train of thought.
Then what the hell?
Like, PQR, what's Q? I was like, okay, no. You know, the thing, like, the weird thing is, like, you might not think about it consciously, but, like, those questions that just get spammed out, like,
Ow.
actually occupy processing in your brain. Like, it's actually in my brain's like, what is Q? What is Q? Answer the question.
Q is
Yeah.
Q is a letter of the English alphabet.
No, I'm sure you're doing the same thing. It's just the difference is I'm speaking first, I guess. That's the only difference. Just speaking
How are you
random thoughts.
flashing so quickly?
Alright, okay, so
How do you move so quickly?
Some like police are like
So
I don't know,
weird.
like the stick
I never
out there.